We're going to be doing Cambridge Igcse Paper 1. Questionables are applicable for both the core and the extended candidates, and the topic for which we're going to be solving the MCQs today is carboxylic acids. The first question states that after this, we're going to do the extended only. The structure of an organic compound is shown. This is the organic compound. The first thing whenever you see an organic compound is to identify the functional group, right? So I think over here there are two functional groups that are pretty visible. First, the carbon double bond carbon, which tells that this is a alkene, right? And then the second functional group is this part. You just don't have to see the COH, otherwise you're going to think it's an alcohol. You have to see this entire part, which shows that this is a carboxylic acid. The compound is tested separately with thiamophthalene and with aqueous bromine. So thiamophthalene is basically an acid base indicator, and if thiamophthalene is an acid base indicator, that means it's going to change color in acid and alkali. So in acid, thiamophthalene is colorless, so the color of thiamophthalene is going to be colorless. And then for aqueous bromine, you know that whenever you have an alkene functional group, what happens to bromine? Bromine is Br single bonded to Br, and what happens is that since you have a bond between the two bromines, the color remains brown, or you can say orange. But when it's added to the alkene, this bond breaks. One bromine gets attached here and one bromine gets attached here, and then the solution becomes colorless. So aqueous bromine is gonna be colorless. Whenever there's a carbon double bond carbon, that's gonna make the bromine go colorless. Next states that which row describes the properties of aqueous ethanoic acid. Ethanoic acid is an acid, so definitely it's going to have a pH. 7 pH is neutral pH. All pH that are above 7, which is 8, 9, 10, and you go further, and which are below 7, which is 6, 5, 4, these are the acidic pHs, whereas these one are the alkaline pHs. So pH is going to be definitely less than 7. We are not going to 1 because ethanoic acid is a weak acid. Why? Because it is an organic acid, right? Organic acids are weak acids. Inorganic acids are strong acids. So this is ethanoic acid is weak acid. The more stronger acid it is, the less the pH. So 1 is going to be of a stronger acid. 4 is going to be of a weaker acid. So it's going to be 4. Next, effect of adding magnesium. Definitely whenever you have an acid and you add metal to it, which in this case is magnesium, you get hydrogen gas. Effect of adding sodium carbonate, you add carbonates to acid, you get carbon dioxide, water, and a salt. So reacts to form carbon dioxide and water only. No, this is salt as well. Reacts to form salt, carbon dioxide, and water. Well, this one's correct. And since you're adding sodium carbonate, so what's going to be the name of your salt? It's going to be sodium ethanoate, okay? And since you are adding magnesium, the gas is going to be produced as hydrogen. With that, you're going to also produce magnesium ethanoate salt. Next, which substance reacts with aqueous ethanoic acid? You have an acid, metals react with it, carbonates react with it, and oxides are also gonna react with it. So 1, 2, and 3. Which statement about ethanoic acid is correct? It turns universal indicator purple. No, it's gonna turn it red. Why? Because acids turn the universal indicator red. It reacts with magnesium to form hydrogen gas. That's correct. All acids are going to react with magnesium to produce hydrogen. It reacts with calcium carbonate to form carbon dioxide gas. That's correct. Acid plus carbonate gives carbon dioxide. It decolorizes aqueous bromine. No. Decolorization of aqueous bromine happens when you have alkenes, when you have a carbon-carbon double bond, which in this case is not present in ethanoic acid, because ethanoic acid is simply this. Okay, so 2 and 3 make sense. Which row about aqueous ethanoic acid and dilute hydrochloric acid is correct? Firstly, you should know that ethanoic acid is a weak acid and this right here is a strong acid. Both contain carbon. No. Both don't contain carbon. So we're going to go with C or D. Why? Because ethanoic acid is this. It contains 2 carbon atoms, but for HCl, there's just a hydrogen and chlorine, right? Both contain hydrogen. Yeah, that's correct, because hydrogen over here as well and here as well. So look, one hydrogen, 2, 3, 4, and then one hydrogen here. So both contain hydrogen. Yeah, both contain hydrogen. Both react with carbonates. Yeah, all acids are going to react with carbonates. So the line which have all correct is option number C. Which statement about aqueous ethanoic acid are correct? It can be produced by, so now the questions are only for both core and extended unless indicated in a question. So this is for extended only. Which statements about ethanoic acid are correct? It can be produced by oxidizing ethanol with potassium iodide. That is incorrect. You oxidize ethanol with a oxidizing agent. And what kind of oxidizing agent can you use? Well, in our syllabus we have KMNO4, acidified potassium manganate, and then we also have K2Cr2O7, acidified potassium dichromate. So this one's incorrect. It reacts with magnesium to produce hydrogen gas. That's correct. All acids are going to react with magnesium or any kind of metal. Even if there's zinc over here or any other metal, it's going to react. It has an approximate pH of 3. Yeah, that's correct. Since it's not a very strong acid, it's not going to be 1, 2. It's around 3. That's of a weak acid. It produces esters called methanoates. No, since it's ethanoic acid, so the ester's name is not going to be ethanoates, not methanoates. So 2 and 3 make sense. Carboxylic acids react with alcohols and warm with an acid catalyst. Yeah, you know that a carboxylic acid, which is going to be an organic acid, plus alcohol, what kind of substance is it going to give you? It's going to give you your esters. So which type of substance is formed? An ester. Which structure is that of butanoic acid? First we look for 4 carbons. So 1, 2, 3, that's a cross. 1, 2, 3, 4, that's a tick. 1, 2, 3, that's incorrect. Butanoic, but means you're going to have 4. 1, 2, 3, 4, that's also correct. Now after that we need to find the acid functional group. Acid functional group is this. Over here we can find an alcohol functional group. So this is going to be butanol, not butanoic acid, but over here we have a acid functional group. So option D makes sense. Esters are formed when carboxylic acids react with an alcohol. What is the catalyst? We always know we add sulfuric acid. Sulfuric acid is the catalyst for esterification. So you can write a point over here that the catalyst for esterification, that means making esters, is H2SO4, sulfuric acid. The structure of an ester is shown. What are the names of the carboxylic acids and the alcohol that react to form this ester? First, you need to find the ester linkage. This is the ester linkage. You break it from the linkage. Realize that on the right side of the linkage, you have 3 carbons and it has only an O, not the carbon double bond. So this part was your alcohol part, and the part that had the carbon double bond O, this part is your acid part, right? So you have 2 carbon acid. 2 carbon acid means that you have ethanoic acid, and you have 1, 2, 3 carbon alcohol. That means you have propanol. So the name of the ester is going to be propyl ethanoate. So carboxylic acid is ethanoic, alcohol is propan-1-ol. 1 just means that on the first carbon, so if you start the naming from here, 1, 2, 3, on the first carbon you will have the OH. Once you just break it, H is going to attach here. Carboxylic acids are made by the oxidation of alcohols. Which carboxylic acid is produced from this alcohol? So this is 1 carbon alcohol, 2 carbon alcohol. So this is your ethanol, and when you're going to oxidize ethanol, you form ethanoic acid. When you're going to oxidize propanol, you're going to form propanoic acid. When you're going to oxidize butanol, you're going to form butanoic acid. If you have pentanol, you're going to form pentanoic acid. So basically, the alcohol, the number of carbon atoms in the alcohol is the same as that of the acid. It is not changed. So you're going to form ethanoic acid. The structure of ester W is shown, which one gives the name of the ester W, the carboxylic acid and the alcohol. What do? We break it from the ester linkage. Then we realize we have 1 carbon on the O side. So that means that a 1 carbon alcohol, and 1 carbon alcohol is methanol. On the acid side, this is the acid side, C double bond O, we have 2 carbon atoms. That means we are dealing with ethanoic acid on this side. So this is going to form methyl, that's the alcohol part, ethanoate, that's the acid part. So it's going to be methyl ethanoate, and the carboxylic acid is going to be ethanoic, alcohol is going to be methanol. Some properties of a colorless liquid L are listed. Boil is 65. Okay, when added to water, two layers which do not mix. If it was an alcohol, it would mix. What is L? L cannot be an alcohol. L cannot be an acid. Acid was also mixed because your vinegar is your ethanoic acid and it's mixed in water. It does not react with sodium carbonate. If it does not react with carbonate, it cannot be an acid because acids do. It has no effect on bromine water. If it has no effect, then definitely it cannot be an alkene. Hexene is an alkene, so it cannot be an alkene because otherwise it would have an effect on bromine water because all alkenes have effect. So it's hexane. And the last question states, for the acid thing, the reaction of ethanol with acidified potassium manganate is shown. So if ethanol, you add an oxidizing agent, and this H plus basically showed that it's acidified. So that's just for the acidification, not to confuse you. You form your ethanoic acid. Which type of reaction is taking place? Oxidation reaction. Why? Because you're adding an oxidizing agent. You're adding oxygen to it. Just count the number of oxygens. Over here you had one oxygen. Over here you have two oxygens. And secondly, you are removing hydrogens as well. So that's the thing.